Now we're going to start talking about biodiversity threats that are related to human causes. We had a distinction before about global and local biodiversity threats. Climate change is a global biodiversity threats that won't be discussed in this session. We're going to focus now on habitat destruction, invasive species, pollution, human population, and overharvesting. So which one do you think that is the major or the most important threat to biodiversity of the ones that I just mentioned? You think that is habitat destruction? Do you think that is population growth? What is your opinion about this? Well, actually, habitat destruction is the most important threat. It's connected to land use that later on we will discuss. It is not only habitat destruction, land use, it's also conversion of natural habitat to human use. But today we're going to focus on habitat destruction only. When people start thinking about habitat destruction and conversion, they think of, for instance, destroying forests or mountains to get out resources like minerals or coal. But there are other land use changes that we should not ignore. Think about wetland loss or mangrove destruction and think about what are the implications. Urbanization is also an enormous change in land use. And more people need more homes and more places to work. It means that they require to expand. And also, at the same time, they will require more agricultural resources and other things to keep the community, right? One very dramatic example of habitat destruction is shown in the Borneo forest, where almost or a little bit more than 50% of the rainforest have been those rainforests have been cut down so far, and this has been done to transform them into palm oil plantations. This is a dramatic effect on local biodiversity, but also it has devastated local indigenous communities, and also it has affected the regulation of climate system. The devastation or destruction of these rainforests have affected one important species, the orangutan populations in Borneo. Borneo is an island shared by Malaysia and Indonesia, and it is estimated that at least 100,000 of these rare and reclusive forest primates were killed in just 15 years. This represents over half of the region's orangutans. By 2050, it is already expected that we will only have 50,000 of these individuals, many of them in tiny, dispersed, and non-viable populations. So Indonesia and Malaysia produce over 80% of the global palm oil supply. In 1960, the two countries together had about 100,000 hectares of palm oil plantations. These oil palms need moist soil and a wet climate, so plantations are often established in lowland peat swamps. Peat is composed mainly of ancient undercomposed plant material, so draining and burning of a hectare of peatland can release up to 15,000 tons of CO2. More than 70% of the carbon released from Sumatran forest is from burning peat. Indonesia, which has the third largest area of rainforest in the world, as well as the highest rate of deforestation, is now the world's third higher emitter of greenhouse gases. So actually, the smoke from burning peat is often perceived in Singapore, Malaysia, and other surrounding regions. In 2014, at the UN Climate Summit in New York, over 150 companies, including McDonald's, Nestlé, General Mills, Kraft, Procter & Gamble, and others, promised to stop using palm oil from recently cleared rainforests and to protect human rights in forest regions. The second threat that we're going to discuss, but very superficial, in a very superficial way, is the introduction of invasive species that displace resident species. And we have already discussed the effect of these species on changing climate conditions or changing matter and energy flows, right? But what I'm going to just stress is that islands and specialized habitats are particularly susceptible to invasive species. And this is the case of Australia. The damage of invasive species um, has been quantified in terms of Australian billions of dollars. So we know that one of the the main problems of invasive species is led by the cats. But there are some other animals like the fire ants, rabbits, even pigs and foxes, and also especially also plants and other type of material. And that's why Australia is very strict on the borders to avoid the introduction of new species. Another local factor is pollution. A lot of attention has been given to big disasters, like Chernobyl disaster. But we also need to consider other constant pollutant inputs into the environment. For example, the degradation of local habitats through human activities that cause downstream effects. Think about, for instance, the leaching of harmful chemicals from mines, like acid mine drainage. This is a drainage with low pH and high metals concentration that have devastating consequences. And here we also show examples of other pollutants that are actually constantly released into the environment. So waterborne pollutants can pop out in very unusual places and have really big downstream effects. So for instance, they could affect reproductive viability of organisms because they can contain medicines and material that can mimic hormones. So they can affect reproduction, and also they can affect the DNA of the animals. There are also pollutants due to the extensive use of fertilizers. And these pollutants are nutrients actually, nitrogen and phosphorus that if it's released into the environment at high concentrations, they can disrupt ecosystems and they can affect the balance in biodiversity. Another pollutant that you don't immediately think that is a pollutant is noise. But noise affects birds and mammals in the ocean, and they can affect the behavior and the reproductive patterns. So noise can also be a major threat for marine life. So this also there is evidence, like with noise, that light also affects is a sort of a pollutant. Let's talk now about population growth. This is one of the major threats to biodiversity, and only because our existence. We are over 7 billion people on the earth. So the more people you have, the more reproduction you have going on. So that's why we, at the moment, we have an exponential growth that you can already see on the figures, on the graphs, right? It is exponential, but there should be, or we can have also a limit, and a limit is something that is called carrying capacity. And the concept of carrying capacity was at first introduced by Thomas Malthus, and basically he said that the Earth can indefinitely support an ever-increasing human population. And Malthus, what he argued was that there won't be enough food to supply the overall population. The estimations of the predictions of Malthus didn't have the effect that he was expecting, only because technology helped us and the improvement of techniques for getting food, and also the progress in the pesticides and the use of pesticides and fertilizers allow to have more good food supply for the humanity. But this doesn't mean that we can actually achieve or we can reach the level where things cannot go beyond. So it has been calculated that the Earth could support an estimated of 40 billion people. But these estimations are based on having big changes in the way that we live. And this requires sacrifices from the humanity. So also this is not an even number among well distributed among the world. We have to be aware that the distributions of resources is not even among the planet, and we also have to recognize that resource utilization is much higher in some countries than in others. So it is very interesting to know that the world's wealthiest 16% of people on Earth use 80% of the available resources. So what does this mean really for biodiversity? The concept of carrying capacity should not be new for you if you think about the logistic growth equation. In the logistic growth equation, we have one section that is like the exponential part, where the population or is affected only by a constant value, and this is the growth rate, right? And this can be translated into fertility or into other constant values that can affect the growth. But then the other section of the logistic growth equation has the component of the carrying capacity, which is a value that has the same units as the population and can tell us the limit, right? So the first section is the exponential part, and therefore it is believed that we are still on this exponential time, but at some point we will have to we will achieve the reach the carrying capacity value. And there are different examples who have in history who have told us the fatal final that we can have. Think about the Easter Island. Humans that were the first settlements in the Easter Island, it is believed that they died because of the lack of resources and the fact that they were stuck in an island and they could not live. So this would be a very dramatic scenario where we don't have a logistic growth behavior, but we can have an overshoot and collapse, which is when there is no more resources because are limited, and there is no way back, and we will get extinct. The impact of population growth is so significant that scientists have just done estimations or models based only on growth and not based on other factors that we were discussing, just as agriculture practices and other things that can threaten biodiversity, and they have seen a direct correlation between species richness and population growth. And the number of threatened species in average, it is expected to increase for all nations by 2020 and 14% by 2050. Another important biodiversity threat is overharvesting. There are classic ways we use resources like hunting or cutting down trees for firewood, etc. But there are other threats, major threats, that connects overharvesting, like for example overfishing. The way that fishing is now carried out is completely different as in the past. Now we have large-scale industrial fisheries where we are basically cleaning large tracts of oceans, and not only in shallow waters but also in deep ocean regions. We're learning, unfortunately, that once we cross the tipping point with regards to loss of fisheries, we can actually lock the system in a situation where the fish does not even come back. Overfishing affects other species because of the interactions that they have. For example, when we lose more than 30% of fish stocks, there is an abrupt impact on the decrease of seabird populations.